is we're going to manipulate special right triangles. So could you do me a favor? At the top of your page right there, you should see 2 triangles, and we're going to bedazzle those a little bit. We're going to decorate them. I think what you're going to see off to the side here is one of the most egregious typos I've ever seen in a math book. I had to write in the 2x. So can you do me a favor? Make sure your 2 is there. Is your 2 there? You have a 2? Yes, yes. Okay, okay. Because sometimes I save things on the PDF file, and then when you guys pull it up, it's not there. It's very upsetting. Anyway, this is going to be our first triangle of study today. Notice we are still working with right triangles. So we have a 90-degree angle, and then the very first special type of right triangle we talk about is your 30, 60, 90 triangle. However, what you need to remember is that those have radian measures associated with them. So the switch on the 30 is that guy's going to be pi over 6. Let me grab a different color here. So you can add that into your notes. 60, does anybody remember what that is? Nice. Okay. So that's pi over 3. And then does anybody remember what 90 is? Close. That guy's pi over 2. So the shift we're going to have to make in a little bit is that, yes, this is a 30, 60, 90 triangle, but you could also look at it as pi over 6, pi over 3, pi over 2. Notice that these angles, 60, 30, add up to 90. 90 and 90 makes 180, so we have a nice triangle here. Okay, I actually give this triangle, so what's important about this is the side lengths, because we're not using SOHCAHTOA to figure out the sides today. We're going to use the fact that something is always true on this triangle. It's so true I gave it a nickname. I call this the 1, 2, 3 triangle, or right triangle. This is designed to help you remember what side is what for the quiz tomorrow. If I could spell triangle, that would be good too. There we go. So you might be saying, why is this the 1, 2, 3 triangle, Mrs. Lucas? Well, allow me to explain. First of all, we need to think back to geometry. I know, maybe a scary time for some of you. But we had this thing called the triangle inequality theorem. And basically it says this. If you want to look at an angle as like a mouth, like I'm going to trace my 30-degree angle right here. And this, it's kind of a big mouth. It goes all the way up. You don't have to draw this in, purely for your visual entertainment. And this guy has some teeth. Does everybody see the mouth? It's like an alligator. The smaller the angle, the smaller the size of the mouth. The smaller the angle, the smaller the size of the mouth. Yes, the smaller the side it can actually eat. Like this mouth is chewing right now on this side, right? Small angle eats a small side. Big angle, which has to be the 90-degree angle, has to eat the biggest side, our hypotenuse. And then the 60-degree angle eats a side that's in between those two numbers. Okay, so what you need to understand, we don't know anything in particular about this side length, just that it's going to be the smallest side. That smallest side is so small, we just call it x, or 1x. So that's where the 1 comes from in the 1, 2, 3 I'm talking about. Scroll down a little bit, remember? So that's the 1. That's just because it's 1x across from your 30-degree angle. To get the largest side, you just double that. So that's where the 2x comes from. 2x is going to be your hypotenuse. And then the 60-degree angle has to eat a side length that's somewhere in between 1 and 2. So it's not actually 3x, because if I made this bottom number here 3x, well, that would then have to be the biggest side. So we can't call it 3x. Instead, a number between 1 and 2 is the square root of 3. I think it's like 1.8, something like that. I'm sorry, I don't have that memorized. But the square root of 3 is a number between 1 and 2 because 60 degrees is an angle measure that's between 30 and 90. So that's where the 3 comes in. So it's technically not the 1, 2, 3 triangle. It's the 1, 2 square root of 3 triangle. Let's keep in mind the goal. The goal for today is just to find the lengths of the sides using this particular identity. For those of you about to crush the March SAT, I will let you know this is kind of a hot topic on the SAT. There isn't a ton of trig on that SAT, but this is one of those things. So every version I've ever looked at has some special right triangles on it. Kind of a hot topic. Okay, so the goal is just to find the side lengths. So let's scroll down a little bit. We're going to do a couple of them together. For instance, problem number 1. You want to locate that one for me? Step 1, just like you did in last night's assignment, you label the triangle. But this time we're not going to do opposite, hypotenuse, adjacent. This is a 30, 60, 90 triangle. So I'm going to label it so it matches the picture we just doodled up. So what we know is that this side length that's 6, that's across from the smallest angle. So that has to be x. The hypotenuse is across from the 90-degree angle. That has to be double the length of your short side. In other words, it has to be 2x. And then lastly, the side that's somewhere in between, that's your 60-degree angle. That 60-degree angle is going to eat a side length that's in between, so that's going to be x square roots of 3. And honestly, the goal is to find x. And in this example, it's pretty easy. Does everybody see what x is equal to? X is equal to? 6. That means that wherever there's an x, I can replace it with a 6. So instead of writing 2 times x, to find the length of the hypotenuse, I'm not going to do 2 times x, I'm going to do 2 times 6. Because what we've established over here is that x is 6. So I now know the length of the hypotenuse. I can figure that out by just multiplying 2 times 6. 2 times 6 is 12. So the hypotenuse on this triangle is 12. So the longest side is 12. Our hypotenuse is 12. The shortest side is 6. I just have to get that third side there in red, the side across from the 60-degree angle. Remember that x was 6. So instead of writing x square roots of 3, we can fill in what we know about x. X was 6. So this is just 6 square roots of 3. We really can't use the product property on that because the 6 isn't in a radical. So 6 square roots of 3 is that third side.
Oh, we don't have to like do it? I made it 10.4, but I don't think that do it.
No, you can just leave it as a radical. You can leave it exact. You don't even have to do that. When I write my answers, I always write them from smallest to largest. So 6 was the short side. 6 square roots of 3 was the middle or medium side. And then 12 was your hypotenuse. What we're doing right now, it's called solving a right triangle. Whenever you find every angle and every side, the task at hand is solving the triangle. So we have successfully solved that triangle. We know every side and we know every angle.
Is that all we have to do?
Yes. I'm going to take it up 1 notch. I'm going to do another one with you. So we have one more triangle to do. We have 45, 45, 90, but let's crush this one. I'm going to do one more with you. I'm going to pick a number 6. Let's do that one together. Bless you. Bless you.
Thanks, guys.
Okay, so step 1, you label the triangle, right? So the short side is x. The hypotenuse, that's 2x. And then 27, well, that's going to be our x square root of 3 side. So it's that 1, 2, 3 triangle. So you have 1x, 2x, x square roots of 3. It's like a little mantra. 1x, 2x, x square roots of 3. 1, 2, 3 triangle. Now this time around, they weren't so nice to you. They didn't give you the short side. Whenever they give you the short side, it's a lot easier. What did they give you now? Those jerks. They gave you an equation. That's all that is right there. So they gave me something like a clue to solve for x, which we did in chapter 3 in our algebra 3 class. So we would take x square roots of 3 and set that equal to 27. So if I want to solve that equation for x, just have to divide both sides by the square root of 3. So the square root of 3 over the square root of 3 is 1. And then we have 27 divided by the square root of 3 as our answer. Not quite done yet, though. There's this ticky-tacky little rule from Algebra 3. You can't leave a square root in the bottom of the fractions. They may remember how to get rid of it. You do. Yes. So you multiply the top and bottom by the square root of 3. Good job. Sure. So I multiply straight across the top, so that's 27 times the square root of 3. And then the square root of 3 times the square root of 3 is the square root of 9, which is 3. Ugh, we got a fraction that reduces here. So I can reduce 27 over 3. That is 9 square roots of 3. So that is the value of x. So x is 9 square roots of 3. So wherever I see an x, I'm going to replace it with 9 square roots of 3. The first thing that's going to go is that jam right there. That 1x, I know what that is now. I solved for x, which is kind of nice. You know, at least we find a side. So this side right here is 1x. 1 times 9 square roots of 3 is just 9 root 3. And then instead of doing 2 times x to find the hypotenuse, x is now 9 root 3, so I got to fill that in. I would probably just reassociate this multiplication, do the 2 times 9. 2 times 9 is 18 square roots of 3. And that's done. I usually write my answers from smallest to largest. So our answer, we have, for the short side, we have 9 square roots of 3. And then we have 27. And last but not least, we have 18 square roots of 3. If you plug them into the Pythagorean theorem, I'll let you know it works. A squared plus b squared will equal c squared. So that's another way you can check yourself. I also give you an answer key, so it should be pretty good. Okie dokes. So that's the first triangle. There's only one more. We're almost done. It's actually the easier of the two as well. And that would be because it's isosceles. So once you have one side, you have the other. They're the same. So this is our 45, 45, 90 triangle, or we could say it's pi over 4, and then pi over 4, and then 90 is pi over 2. But this is isosceles, which means that this side here is congruent to that side there. Remember those little tick marks on your triangle? You put the little hash marks on there, and that indicates your congruent sides. So if this side is x, you know, we could call it 1x. This side is also 1x. And your hypotenuse has to be a little bit bigger because it's the biggest side. But it can't be 2x because that's the hypotenuse on the other triangle. So we need something that's a little bigger than 1, not quite 2. If you do it in the Pythagorean theorem, you get x square roots of 2. So this triangle I call the 1, 1, 2 triangle, or 1, 1 square root of 2 triangle. So if you need to remember the coefficients, you have a 1, 2, 3, or 1, 2 square root of 3, and then a 1, 1 square root of 2 triangle. The problem-solving technique is exactly the same. I'm going to label the triangle first, and then I'm going to use it to figure out the sides. Everybody have all their labels? Feeling good about it. Woo woo. Okay, let's crush this. So, what do we got here? Oh yeah, this one's not bad. So number 2. First thing I'm gonna do is label it. So here's an X, here's an X. This guy, this hypotenuse here is gonna be X root 2. So what's nice is they come right on out and they tell me what X is. X is 9, which means this is also gonna be 9. Everybody sees why those sides are 9, because in an isosceles right triangle, 45, 45, 90 triangle, you have 2 identical sides because you have 2 identical mouths. The mouths have to eat the same sized sides. All right, last bit. So this hypotenuse is X root 2. We know what X is. It's got to be a 9. So this side here is just 9 square roots of 2. So if you're writing your answers, smallest to largest, 9 and 9 are the same. 9 square roots of 2 is a bigger number. So that your triangle is solved. You found every angle and every side. I also wanted to do one of these where I gave you the hypotenuse, because that is the harder case. Oops, I'm on the wrong side of the paper here. So I thought it would be a good idea to do number 5 as well. So again, step 1, let's mark this triangle up. X, X. 32 is X square roots of 2. Excuse me. So now I just need to figure out what X is. I'm going to use this equation that's chilling here. I got to get this X by itself. So again, I got to divide both sides by the square root of 2. That is a little annoying because I can't have a square root on the bottom of my fraction. I'm going to take Annabelle's advice here, multiply the top and bottom by the square root of 2. So you got 32 square roots of 2. Square root of 2 times the square root of 2 is 2. Mainly, square root of 2 is the square root of 2. Square root of 2 times the square root of 2 is 2, because if you multiply these things together, you get the square root of 4. So the square root of 4 is 2. And then we would want to reduce, right? You got 32 over 2 there. Yeah, it is 16. So this is 16 root 2. And you actually, since you found X, like, that's what your sides are. So this is 16 root 2. And the other side also has to be 16 root 2. So if you're putting your answers in order, 16 root 2, 16 root 2, and then the hypotenuse is the biggest number, that's 32. So that triangle is solved. And that's how you solve your special right triangles. So just kind of summarizing a little bit. You got your 1, 2, 3 triangle. Short side's 1x, hypotenuse is 2x, medium side is x root 3. And your 45, 45, 90, that's a 1x, 1x, and x squared is 2. So this is the stuff you need to know for your quiz. You'll have a quiz on these types of problems tomorrow. It looks exactly like the assignment.